One of my favorites is this cross-layer tornado cache. Imagine that you can deposit some tokens into the shielded set on L1, and then you can withdraw on L2. Very seamless user experience. Or imagine that you deploy your dApp on an L2 that doesn't have ENS. In this case, you could just use L1 SLOAD to directly look up names from the L1 ENS. Another example is DeFi. So you could create a DeFi dApp where you can borrow on L2 by directly using collateral on L1 without bridging this from L1 to L2. And for account abstraction wallets, you might have heard about key stores. The idea is that you manage all your keys on one chain, let's say on L1, and when you update your keys, you add or delete a key. This update is automatically propagated to all your wallets on all the chains. So this last example would look like this. In the L1 contract, you would most likely have some kind of a mapping where you store the authorized signers. And on L2, it's very simple. You just calculate the storage slot that you're interested in, and then you can call L1 SLOAD read bool. The sequencer fetches the data for you, and you can decide in your L2 wallet whether this signer is authorized or not. So L1 SLOAD makes this very easy to implement and also very easy to use as a developer. Now that you have a general understanding of what is L1 SLOAD and what are some use cases, let me talk about why do I think we need to provide this in the sequencer level. And the way I think about this is that this is a service that the sequencer provides to you, basically MPT proofs as a service. Because this is all doable already without relying on this precompile, but it's very complex as a developer. First of all, relaying the state root information from L1 to L2 in a verifiable way is very complex. And then for any interaction on L2, providing this MPT proof is costly and also complex to develop.